Hello students, if you remember, in last period we have started with sound wave and we have seen most of the part of the sound wave that we have finished. Now today we have to go to the next topic about syllabus, that is nothing but what? Qualities of sound. What are the qualities sound have that we have to learn under this topic? Before this we have learned different factors which are affecting the velocity of sound wave, that already we have learned. Now today we have to go to the qualities of sound. So basically under this topic qualities of sound means what? How can we distinguish the sound wave? We can distinguish the sound wave by using three different basic quantities, and that three basic quantities comes under this. They are said to be qualities of sound. Now the first quality they have mentioned in your book is nothing but a pitch. So let's start with this pitch. What exactly pitch means? If all of you are well known about, little bit well known about the sound, the classical music, or how to sing the song, then you are well known about what is meant by pitch. Pitch is basically, this is nothing but what? It is related to this, whether the sound is shrill or sharp. Sound is shrill or sharp. That was decided by this factor, and that is said to be pitch. And that sound will be either sharper or it will be shrill depending on the frequency of sound wave. If we increase the frequency of sound wave, we can say sound becomes more and more sharper. So in that case, the change in frequency result into change into the pitch of that sound wave. Whenever frequency of sound wave get changed, means pitch get changed. So that is nothing but a pitch of the sound wave, one of the quality of sound. In this case, they are just given in your book. The sound of double frequency is doubly sharp. If the frequency is double, then sound, so the difference between the two waves. Suppose we have taken the first sound wave. Suppose the first has a frequency f. First wave has a frequency fa, and the second b has a frequency 2f. It is double of this initially. So we can say that this sound is doubly sharper than this one. So this is very sharp as compared to double sharp as compared to this, and this is a little bit shrill. It is not sharper that much as this, and that is nothing but what? Frequency changes, sharpness or shrillness of the sound get changed, and that is said to be pitch, one of the quality of the sound. Apart from this, they have just given in the book the last paragraph of this topic. Just they have before last paragraph they have just mentioned here. So here tone, just they have discussed the tone. Tone of guitar are sharper than that of beat. Tone and beats are the part of the music. So tones of guitar, if you are playing the tones by using guitar, they are more sharper than the beats. Beats are again one of the phenomenon which relate to sound wave, that is nothing but related to music. So the in case of guitar, guitar is an instrument to play the music. If you play in the guitar, if you play the tones, they are very sharper as compared to if we play the beats by using the same guitar. The tones are sharper. Apart from this, might be all of you are well known about tabla. Tabla is sharper than that of dagga. Dagga means literally again one of the musical instrument. The sound produced by dagga is not that much sharper as that of tabla. Tabla will produce a very nice, very sharper, high frequency sound, means high pitch sound. Frequency is higher means pitch is higher and sharpness is higher. Apart from that, they have just mentioned one of the most important parameters they have mentioned. In general, female sound is sharper than that of the male sound. Just it's very important to remember. Female sound, mostly in human being, the female sound is very much sharper than the male sound. That's why sometimes when if you have a habit to learn the music, you can learn the music if you have a habit to hear the music, not to learn, hear the music. Then you might have explained that the human beings are very melodiously singing the songs, but still it's very sensitive to the female voice rather than the male voice, because in general female voice is sharper than the male. So that they have mentioned here. Apart from this, might be if you have a sound system at your home, there is one knob to the sound system. It is said to be treble. Treble is one of the knob given to the sound system. If you move that treble, means what get changed? Frequency of sound get changed, means the pitch get changed. So that is nothing but one of the example they have given. Let's start with the second one. Second one is said to be timbre or quality. It is said to be timbre or it is said to be quality. So this is one of the quality of sound in which we can differentiate the different sound wave, that is said to be timbre or it is said to be quality. One of the best example they have given under this topic, suppose someone call you, your friend or relative call you, and you have not saved the number, still you can recognize who is speaking to that side. Why so? Because you are able to hear, you are able to distinguish the voice of that person, and that is nothing but what this property, you are able to know who is speaking to other side. If that is well known to you, you can identify that particular person without knowing the number. How it is possible? That is possible by one of the parameter that is said to be timbre or quality of sound. How much is the timbre or how much is the quality of sound, but that will decide who is speaking to that side. So this is nothing but remember, if you know the person who is speaking from that side, then and only then you can identify. Otherwise you can't identify that person, and it is possible to identify that person because of this parameter of sound that is said to be timbre. Some song play on guitar and violin, harmonium, piano feel significantly different. If the same song is played on guitar, same song is played on violin, harmonium, but still you can just remember that song is same, but the instruments are changed, and that's why we can hear different sound, different quality of sound we get, and that is the property of the sound that is said to be timbre or quality. So here the quality of sound of any sound instrument, that will depend on the mixture of tones or overtones. Mixture of tones and overtones. Might be suppose someone get angry, his speaking tone get changed. Sometimes we are just telling him that some student is speaking some loudly, then we say that your tone is changing. Your tone becomes overtone. Overtone means what? Your quality get changed, your timbre get changed. Person is same, but its tone get changed, and that is nothing but this timbre. That is one of the parameters they have mentioned. Apart from this, suppose in early in the morning I have called some students. Suppose I am not going to call you. Suppose early in the morning some teacher call you or you call to teacher. At that time you can recognize whether that student is sleeping or it is awake earlier, wake up earlier, or the student is sleep. That can be understand just by hearing a voice. If the voice is clear and sharper, we can say that person is wake up earlier. But if the voice is little bit lazy, we can understand that that person just wake up due to my call. Apart from this, again one of the most example they have given, suppose I am feeling from cough and fever, suppose cough and fever or cold. I am suffering from cold and cough. At that time my voice gets changed. Every people has different voice when that person is suffered from cold and cough, definitely. And throughout the day, in the morning, in the evening, in the afternoon, little bit changes are made there in the voice of the human being, and that is done because of this parameter timbre or quality of sound get changed. Early in the morning it's very lazy voice. Why it's lazy? Quality is poor. That means we got timbre is poor. As he wake up, wash his mouth, brush, and so just take a cup of tea and so on, his mouth become his sound becomes more and more sharper. Quality get increased, timbre get increased. So that parameter comes under this. That is second, quality or timbre. And third one is nothing but what? Loudness. What exactly loudness is? Loudness means what? The intensity of sound. Intensity of sound produced, that is said to be loudness. Sometimes some teacher is going to taught you any subject. At that time there is a probability that even second bench or third bench students are unable to hear the voice of the teacher. Some cases, some teachers are there, they are going to taught you any subject, suppose, and if third bench or fourth bench students are unable to hear the voice of teacher, what will occur to fifth and seventh bench of the students who are sitting on the fifth and seventh bench? What will occur? They can't hear. Why can't hear? Because if third bench student can't hear the sound of teacher, then how it will hear by seventh bench student? It's not possible. That means what? In that case, the intensity of sound in with which the teacher is teaching is very small. Intensity is small, so the sound wave can't travel that much distance, and that part comes under this, that is said to be loudness. How much loudly the teacher taught you, that will decide how much long the sound wave will travel. That is nothing but intensity of sound wave. can be measured in terms of this parameter that is said to be loudness. Loud sound means what? Loud sound means what? Very, very big intensity sound. Less loud means what? Even the first bench students are unable to hear the sound. That is nothing but this loudness. And here, before going into loudness, here they have just mentioned intensity of sound wave is found to be directly proportional to square of amplitude of the sound wave. A is said to be amplitude, I is said to be intensity of sound wave. So loudness depends on intensity, loudness depends on intensity, intensity depends on square of amplitude. So this is a relation that you have to remember. So in this fashion, apart from this, if you remember, recently within 2 to 4 years ago, just government is concentrated on the voice. What are the pollutions? There is one type of pollution that is said to be sound pollution, that can be heard in marriages. Might be if you attend the marriages, there is a DJ, big sound they are using. That DJ are producing the sound pollution. Apart from that, firecrackers, they are producing the sound, and that sound pollution can be measured. How much the sound intensity is there, that can be measured by using the unit that is said to be decibel, or it is bell. Bell is one of the instrument. Apart from this, the another instrument is what? Decibel. That they have given here. Decibel is a instrument. Decibel is an instrument. It is measured in dB. dB for unit of measurement of sound intensity, decibel. Smaller units are bales also. Bales and decibels, these are the unit to measure the intensity of sound. Apart from this, below this, in the same topic, just they had tried to solve some equation. It is not essential to learn that equations. So all of you have to prepare yourself for these three topics. What is meant by pitch? It is a frequency. Timbre or quality, we can identify sound by using this one. Third is loudness, loudness of sound. Decide how much distance it will travel. Now let's go to next. There is one another topic. Next topic is what? Doppler effect. What this Doppler effect is? Might be all of you have heard about the Doppler sonography. Might be Doppler sonography you have heard about. Now similar to this, there is one effect that is said to be Doppler effect. What exactly this Doppler effect is, that we have to learn. As it comes in sound wave, so it is one of the effect of sound, as well as Doppler effect was produced in light also. So first of all, concentrate to learn Doppler effect of the sound wave. Suppose all of you are stand on the railway platform and train is coming from that side. Suppose this is a railway platform here. This is a platform this is, and all of you are standing here. Suppose we are standing here, and here the railway is coming from this side. This train is coming from this side. Means what? We are study, and we are just observing. Means we are what? Observer, or we can say listener. We are listener, and this train is moving, which gives some sound, and that is said to be source of sound. So this is a source of sound which will produce a sound wave, and this is a person, or we are standing on the platform, we are the listener. So when train come toward us, it is seen that as train come close to us, intensity of sound heard by listener is much more. Okay, as train is arriving toward the listener. Apart from this, if train is moving away from the listener, this is the train, it is moving away from the listener, it is seen that intensity of sound heard by the listener decreases. As train is moving away, intensity of sound heard by listener decreases. But train is coming toward listener, intensity get increased. This case we have just seen, listener is steady and train is moving. Apart from this, another case we can say, if the train is standing here, it is at a steady position. Now here listener is steady. Suppose train is not moving, it is steady position. Listener is moving toward the train. Listener is moving toward the train. Train produces sound wave. Listener is moving toward. The intensity of sound here would be increases because it is moving toward the train. If the listener is moving away from the train, intensity here will be decreases. Such type of effect first time studied by Doppler, and that's why it is said to be Doppler effect. What is Doppler effect then? When listener or source both are steady, or any one of them is moving toward or moving away from each other, or both of them are moving toward or moving away from each other, intensity of sound heard by listener changes, and that changes occurred because of relative motion between train and listener, and this was studied and that name given to it as a Doppler effect. First time studied by the Doppler. For this is for sound wave, so that is said to be Doppler effect. Now the changes in the frequency can be studied under three topics. Just they have given three. First, when listener is stationary, we are standing on the platform, stationary, source is moving. Source is moving means what? Either train is coming toward you, we are studying, we are coming toward, the source is coming toward you, that is the first case, or the source is moving away from us, that is the first case. Second case, when listener is moving but source is stationary, train is steady, the person is moving toward a train or moving away from the train, that is second condition. And third one, when listener and source both are moving toward each other or moving away from each other, that is the third condition. Now the next topic of your syllabus or in your book, the next topic what they have mentioned, just they have given source moving, listener stationary. They have just tried to derive the equation. We are not going in detail of derivations. Directly we are using the formula. So just before going into detail, further detail, there is one table 8.2. In that table what they have done, approximate decibel range of some audible sound. Just if we read it, they have just given here some of the audible range. Loudness they have given an effect. You see, if extremely louder sound we hear, just like a DJ sound with highest intensity, it is 160 dB. Suppose it is 160 dB. What will occur with human being? Just effect they have given. Immediate ear damage. Our ear get damaged immediately. 160 dB. So it is dangerous to us if the sound wave is 160 dB. And in this fashion, if the sound has a decibel, 30 decibel sound is there, it is said to be virtual silence. If 30 decibel sound wave get produced, it is said to be silence atmosphere. If 110 decibel sound is there, it is said to be strongly painful. It will pain the human being. 70 dB, it becomes uncomfortable. It will make uncomfortable to the human being. 70 dB, 30 dB silence, 70 dB uncomfortable, and 110 strongly painful. 150 rupture the eardrum. We have eardrum in the ear that get ruptured at 150 dB. 160 dB immediate ear damage. Our ear get damaged at 160 dB. So it is not good to hear the music with the higher voices. Just recently students and people are using headphones and they just increase the sound. That's not good because it goes beyond this limit. Definitely it will harm yourself. So we are not going in detail of this derivation now. The next one, listener approaching to stationary source with velocity, that part is skipped. The next topic is there on page number 155. There is a topic 8.9.3. Both source and listener are moving. That we are going to learn. Both source and listener are moving. Both source and listener are moving. Moving means what? Either they are moving toward each other or they are moving away from each other. So they have given one equation here that I will write here. N equal to N0, N equal to N0 in the bracket V plus minus VL divided by V minus plus Vs. I hope it is seen. Yes, same. Equation 8.24 from your book. N equal to N0, N equal to N0, V plus minus VL divided by V minus plus Vs. Now what exactly this means? V means velocity of sound wave. So this V stands for velocity of sound. And how much is that? Approximately 332 meter per second velocity of sound. What is VL? VL stands for velocity of listener. Velocity of listener. Vs stand for velocity of source. Velocity of source. Okay. Now here this topic they have given this much quantities. Apart from this, what is this N? And what is this N0? This N0 stand for original frequency of sound. Original frequency of sound produced by source. Produced by source. Original frequency of sound produced by source. What is N? Small n is said to be apparent change in frequency heard by the listener because of relative motion of source and listener or both of them. Frequency heard by observer or listener would be less than the original or greater than the original due to their motion. They are moving toward each other or any one of them moving away from each other. Due to that, actual frequency heard is an apparent change in frequency heard by the observer due to relative motion. What is the original frequency of sound? N0, is it? So that part, this formula all of you have to remember. Apart from this, now if you see in this formula, there are two signs they have used to right hand side. Two signs, plus, minus, minus, plus. What the meaning of this? What is the meaning of this? Below this they have just used upper signs are chosen if the upper signs should be chosen during relative approach. If this train and listener, either train is moving toward a listener or listener is moving toward a train or both of them are moving toward each other, then upper sign should be used. When the lower sign should be used, if train and listener, if train is moving away from a listener or listener is moving away from a train or both of them are moving away from each other, lower signs are used. Lower signs are used. This point to be remembered. Now suppose the train and listener both are moving toward each other means approaching each other. Upper sign should be used, so we can write formula n equal to n0 v plus vl divided by v minus vs, because both of them are moving toward each other. If they are moving away from each other, this becomes minus at numerator, this becomes plus at denominator, is it? If any one of them is moving, other is steady, still we can use the same formulas. Okay, but point to remember, approaching upper sign, moving away it is lower signs. So let's start with another one. Suppose listener is steady, we are standing on the platform and train is coming toward us, approaching to us. What are the symbols used here? What can be written? N equal to N0 in the bracket. Train is moving, source is moving. Okay, source is moving, listener is steady. What is the velocity of listener? 0. So here it is VL equal to 0. Because it is not moving, it is steady. So N equal to N0, VL is 0. So nothing to use. V divided by V. Now upper signs for approaching. So V minus Vs. So this is the formula. If the source is moving toward a listener, listener is steady. Same way, and listener is moving, source is steady, you can find out denominator Vs would be 0. In this fashion, you can find the formulas for this, whether source is moving or listener is moving or both are moving. We can just calculate this by using this, that is said to be Doppler effect. Now here, the next topic that they have just taken three cases, case 1, case 2 and case 3. Let's start with the case first. So this case first, case second they have taken and case third they have taken. What are the cases? These cases means that we will see. If the velocity of listener and source is same, velocity of listener and velocity of source both are same, both are equal, then we can say the apparent change in frequency here must be equal to original frequency. There is no change in apparent frequency, it is same as the original frequency if velocity of listener and sound is same. Velocity of sound and velocity of listener is same. If velocity of listener is greater than velocity of sound, velocity of listener is greater than the velocity of sound, then what will occur? Apparent change in frequency here could be greater than the original frequency. Original frequency is N0, we can hear the sound with more frequency because they are approaching. Listener velocity is greater than the source velocity. And third and last they have taken, if the velocity of listener is less than velocity of source, velocity of listener is less than velocity of source, the apparent change in frequency would be less than n0. Original, whatever the original frequency, we hear less than that if this condition is satisfied. If this condition is satisfied, whatever the original frequency, we hear it more. If both are same, we doesn't hear any change. Whatever the original frequency, we hear the same. That are the three cases they have given here. Now further we have to go the next of this topic, just what they have done. Just they have just given here the common properties between Doppler effect of sound and light. In case of light, same thing it occurred just like a sound. So here, what are the common properties? Just I will read it once. The first, wherever there is a relative motion between listener or observer and source of sound or light wave, the recorded frequency is different than the emitted frequency. Sound here or light recorded, that would be different from the original frequency of the light or sound if the source is moving or listener is moving or both are moving toward or moving each other. There is apparent change in the frequency of light as well as sound also. This is a common property. Second one, recorded frequency is higher. Recorded frequency of sound or light is higher if there is a relative approach. If both of them, listener and source, if they are moving toward each other, then the apparent change in frequency increases. If they are moving away from each other, apparent change in frequency decreases, frequency lowered. And the D, if VL and VS are much smaller than the wave speed, speed of sound or speed of light, velocity of listener or velocity of source of sound is less than that of the frequency of sound wave or frequency of light wave, speed of light wave or speed of sound wave, then we can write another form of equation. Just they have given change in frequency divided by original frequency is relative velocity divided by original velocity, change in wavelength divided by original length. 8.26 is there. There must be equal to sign between the two terms, delta n by n equal to Vr by V equal to delta lambda by lambda. Then the next one, there will be delta n is said to be Doppler shift, change in the recorded frequency, n minus n0. And finally, just they have given 8.27, n equal to n0, 1 plus minus Vr by V. Vr is said to be relative velocity. The last one, if the velocity of source and observer, observer means is your listener. If their velocities are not along the same line, they are not moving in same line. If source is coming here, it is going like this here, then here, what is the meaning of this? They are not in the same line. Their respective component along the line joining them should be chosen for longitudinal Doppler effect, and some mathematical treatments is applicable. This Doppler effect is applicable if the both objects, listener and object, are moving in same line. If they are moving little bit different line, then the properties get changed. We have to take a component of that. Just we have seen the resolution of vector. So apart from this, the next topic and last topic of the chapter is major differences between the Doppler effect of sound and light. What is the difference between them? So it is very important. What are the difference between the common factor we have seen up till now? Now, what are the difference in Doppler effect of sound and Doppler effect of light? That we have to learn. As the speed of light is absolute, speed of light is absolute means what is never change. Speed of light, I hope all of you will learn about 3 into 10 raised to power 8 meter per second. It never change. It remains constant. That is said to be absolute speed. Only relative velocity between observer and source matters. In case of light, as the velocity of light is constant, then what get matter? Matter is what? What is the velocity of observer or listener, and what is the velocity of source? That will decide the parameter. And finally, who is in motion is not relevant. Who is moving, that is not important. What is important? What is the velocity of listener or source? That is important. That is the first parameter related to Doppler effect in light. Second, classical and relativistic Doppler effect are different in case of light. Classical and relativistic Doppler effects are different in case of light, while in case of sound it is only classical. In case of sound waves, classical Doppler effect we have to use, but in case of light we have to consider the classical as well as relativistic. Relativistic means what? Theory of relativity is there. given by Einstein. If we apply that theory here, in case of light, it is applicable only because it is very higher velocity light has. So we have to just choose the relativistic or theory of relativity. So the classical and relativistic Doppler effects are different in light, but they are same in sound, and in sound there is only classical Doppler effect. Next, for obtaining exact Doppler shift of sound wave, it absolutely important to know who is in motion. Suppose I want to find out change in frequency n minus n0, that is said to be Doppler shift. Then in that case, it is very important to know which is moving, whether source is moving or listener is moving. That is very important to learn. Okay, Doppler shift in case of sound only. In case of light, that is not important. So that we have seen A in the first parameter. In case of light, the who is moving, that is not important, but in case of sound, who is moving, that is important. The last one, there is one, if the wind is present, its velocity alter the speed of sound. If there is lot of wind is blowing, wind is moving, then velocity of sound get decreased, but velocity of light never get changed. So it will matter in case of sound. So wind, flow of wind matter in case of sound, but it doesn't matter in case of light. In this fashion, we have completed the chapter. Now point to be remember, whatever the topic I have taught you, you have to prepare that much topics only, is it? So remaining topic are either skipped or little bit, we have just skipped some topics, little bit to avoid complications. Some equations we have avoided. So all of you have to prepare whatever I have taught you, just prepare yourself that one. So I think it is, I think this chapter is finished, so we have to stop it here. The next chapter might be we start a new chapter, maybe gravitation will start, or we will start a current electricity. Okay, so just try to watch my video. Once you watch it, then try to understand it by reading the same topic from your book. So take care and thank you. Let's see in the next video next day. Thank you.